Now we're going to talk about Ohm's law. Ohm's law is probably the single most powerful electrical equation out there. George Simon Ohm in the mid-1800s, early 1800s, I don't really remember the date. What he did was he took a set piece of wire. Remember, the resistance of wire depends only on the geometry and the type of material. And what he did was he started applying different voltages to it. Remember, voltage was a known quantity in the 1800s. And what he found out was that resistance is equal to V divided by I. In other words, as he applied more voltage to it, he got more current. So if I was to look at it from a mathematical point of view, it's a linear relationship. And the slope of that would be R. And what he found out was that for a set piece of material, the voltage and current depended upon one another. Okay, now we're going to talk about the units involved in this. Now, voltage. Voltage, the units are joules per coulomb. That's what we call a volt. Now, for current, amps is coulombs per second. So now, if I put those together and I say R is equal to V divided by I get joules over coulombs over seconds. Well, when I multiply by the reciprocal, I get joules times seconds divided by coulombs squared. That's really messy. So what we did was, in honor of Mr. Ohm, we call that an ohm, and we use the Greek letter omega for it. Now, it's important to understand really the meaning of those variables. Voltage is really the energy that pushes the electrons. It's not directly energy, it's joules per coulomb, so it's energy per charge. Remember, it's due to a difference in potential energy between 2 points. When we talked about static potential energy, static electric potential energy, there has to be a difference between 2 points in order for voltage to work. Now, I is current, and it's simply the amount of electrons. Well, that's going to be measured in how about I spell right? And amount's got to be measured in amps, which is coulomb per second. Now, I is equal to Q divided by T. Q is in coulombs, time is in seconds, so that's where the amp term comes from. And again, resistance we discussed earlier. Resistance is the opposition to the flow of electricity. Now, an ohmic resistor is something that obeys Ohm's law. In other words, essentially says if that's V and that's I, it's a linear relationship. A non-ohmic resistor doesn't obey that law. It would have something, I don't know, some different type of curve that looks like that. 99% of what we're ever going to deal with are ohmic resistors. So therefore, it's pretty straightforward. It's V divided by I. R is the missing thing. It's the slope of it. Okay, another important equation is the power equation, electrical power. For electrical power, it's V times I. Now, we've also talked about mechanical power, which is work divided by time, and I'm going to show you they're actually the same thing. I'm going to show it using units. Well, voltage, and again, go back 1 second. We buy electrical devices based on power. Most common type stereos and microwaves are the two that you see power advertised, because obviously the more powerful a stereo is, the louder it can go. There's one of two ways you can make a stereo more powerful. You can increase the voltage or increase the current needed to do it. Now, V is joules per coulomb. I is coulombs per second. Coulombs cancel out, leaving with joules per second. That's a watt. Yay! And remember, if we go back to our original power is equal to work divided by time, we get joules per second, which is a watt again. The math gods are happy. I hope this helped. We'll do some practice in class.